Welcome everyone to the second of 4 scheduled webcasts of our TPM webinar series. I am Rose Kopcha from Tooling U-SME and your moderator for today's session. For over 90 years, Tooling U-SME has promoted the advancement of manufacturing by supporting new technology in industry and the development of its workforce to sustain manufacturing. We hope you enjoyed today's topic on autonomous maintenance. You can sign up for the remaining 2 topics on our website at learn.toolingu.com. You will notice on your screen there's a Q&A box where you can submit your questions or comments. We should have enough time at the end to answer any questions you may have. A recording of today's session will be made available on our website at learn.toolingu.com. Also on your screen is our speaker for today, Drew Locker. Take it away, Drew.
Thank you, Rose. And welcome to our second webinar on this series. Hopefully we have as vibrant a conversation as we did in the first one. That was great. Some of you really contributed in sharing at the end, not just a Q&A, but sharing your own experiences, good lessons learned. Hopefully we'll have some of that on this one as well. So the first one was on predictive maintenance, and there's a strong relationship with autonomous maintenance because in predictive maintenance, it's condition-based, and who better to see even subtle changes in conditions of a piece of equipment than the person operating it. So we're going to see some kind of overlap with this one, some of the techniques that we would typically expect not so much techniques, but some of the responsibilities that the operator would have, you'll recognize from the previous webinar. So let's get started. So first, just some definition. It's an approach where machine operators take ownership of basic maintenance tasks for the equipment they operate. So we'll talk more about this in the final webinar of the series, the fourth one about culture. But it always bears repeating that, we're trying to get away from operators operate the machine, maintenance maintains it, never the twain shall meet. And that historic approach, that traditional approach, has often created some ill will between those groups and undermine our ability to achieve, maintenance excellence, as we say. So it's a shared responsibility. And that's where we want to try to make sure that all the parties involved understand and accept. Okay. So why do this? As I kind of mentioned a moment ago, the people closest to the machines, the ones that run it, they really need to be involved in this whole responsibility because they might not be running the equipment in a way that contributes to its reliability. They may be running it in a way that is detrimental to the reliability of the equipment. I'm sure any maintenance technician or maintenance manager on this webinar probably knows a story or several where the operators are not always running the equipment as they should for various reasons. Could be pressures on them to meet certain goals, some measurable goals. It could be they were never properly trained or probably some other things, but those are probably the 2 most common reasons. So this fact is reinforced by operators actively sharing in the responsibility for maintaining it. So it's not a point of confusion. Hey, you're there to run it and help maintain it. Not alone, but partnering with the maintenance technicians or engineering staff, whatever titles they go by in your organization. And the real key again is, they are running it day after day, they're closest to it, and they can pick up even very subtle changes in its condition or conditions. So I always use the analogy of an automobile. No one can pick up subtle changes in the operating of your car than you can. The person driving it pretty much every day. So hopefully that makes the point why we want to get operators involved. But as you'll hear me say several times in this webinar, we just got to be reasonable with what we're asking people to do. So what is required to do this? If it was easy, everyone would be doing it. and not everyone is, but more and more organizations have moved in this direction over the last probably 2 decades. So number one, we need that collaborative relationship. It has to exist between maintenance personnel and operators. And as we get into how we roll this out, that'll become very apparent why. Providing education and training is really needed for the operators to understand the equipment they're asked to run, how to run it, how to maintain it, as well as those conditions that may identify problems early on. Now, kind of jumping ahead a little bit, but who's going to provide that education training? It's usually the traditional maintenance folks. Sometimes we'll call the OEM in, the original equipment manufacturer, if the internal knowledge and experience doesn't exist, which happens sometimes, to be able to teach it to others. But most often it's the maintenance technicians, engineers who are going to provide this training to the operators. So they have to be willing to do it, share what they know, and they have to be effective trainers as well. Then we got to be clear who's responsible for what, right? They're not, operators aren't going to be responsible for everything. So we have to identify the key tasks that we expect them to perform. And it usually involves inspection, cleaning, and lubricating. Those are kind of the initial three. But there could be others, even in the beginning, people might be, reluctant or can't see that an operator could take on some other responsibilities, other tasks, but with a little creativity, more specifically making it very easy to do, then we can even add those tasks that initially people didn't think was possible. But most often it's inspecting, cleaning, and lubricating, but maybe some others. And to my last point, this requirement is really key. Make it as easy as possible for operators to perform. Now I'm getting something from Corey that my audio is choppy and static. Rose, are you hearing that as well?
Yes, if you could perhaps lower your volume a little bit.
Maybe lower the volume. Okay, that could be. Is that any better? Hello, 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 testing.
It's a little better.
Okay. Thank you, Corey, for letting us know. Appreciate it. Hopefully lowering the volume. I was kind of cranking it up. I was probably doing the wrong thing there. So hopefully that's better. All right. So again, these are the basic requirements. Nothing too crazy. Just a lot of the social implications of this is what makes it, I think, challenging. And that leads us to this slide. It's got to be a collaborative approach. And if we're walking into an organization where there's a very strong adversarial relationship, still pretty choppy. Oh, damn. I'm not on Wi-Fi, I know that. I'm on a hard line. Any better, Corey? Any better? Testing 1, 2, 3. Hello, hello, hello.
It's a little better. I don't know that you're going to be able to correct it completely, but it sounds a little better.
And I know last time we tried the headphones and that did not help. It seemed like it was worse. All right. Hopefully it's not too distracting for you all. I apologize. So again, if we're walking into an organization and there's a strong adversarial relationship, we have our work cut out for us. And that often is occurs because of kind of the history, that there's, maintenance has this attitude of, hey, no, I do not have two speakers, Jenny, just the one. So they have this, kind of approach that, hey, I come in to fix things and then I leave. It's kind of the Superman mentality is what we've referred to it as. And that's a problem because they don't always share what they learned in working with the equipment, with the operator. And then there's this ongoing finger pointing that often occurs as well. Operators point to maintenance, they didn't fix it properly, it's not me, and maintenance will reciprocate and point fingers to the operators and say they're not running things properly. So we've got to physically get them together and overcome, if this is a situation that exists, we have to overcome some of this historic baggage that can be pretty difficult to overcome, but nevertheless we have to do it. And the way I learned to do that is to get them, all parties, involved at the very, very, very beginning, just as we're even talking about the idea, before we get into the details. So I cannot change speakers, Jenny. There's only one speaker on the computer. So I could try my headphone again, Rose. You want me to try the headphone? It didn't work last time. What do you think? Or just plow forward? Yeah, I can't change speakers. There's only one speaker. All right, we're going to continue on. Hopefully it's not too bad for you guys. Again, I apologize. We had a little tiny problem last time, but nothing like I'm hearing this time. So getting everyone involved at the very beginning, understanding the purpose of what we're doing, why we're doing it, is key, right? Common purpose makes a group of people a team. So, you know, I was always taught any major, even minor undertaking, change undertaking that represents any level of change, we need to have a purpose for. So defining that up front for everyone, I think, is critically important. So if we can't explain why we're doing this, then we're going to really struggle. All right. So we got to make sure the maintenance technicians don't feel that this is like a negative reflection on them. I'm going to back up a bit. Got a little ahead of myself. You know, because what am I not doing a good job? You know, you got to get others involved. So that's a very common comment that people make. So we've got to have an answer for that. No, we just need all the help we can to make sure that we're doing the best we can with equipment reliability. I will also point out to the traditional maintenance technicians the fact that they've made comments in the past. They pointed fingers at operators. So what better way to kind of correct that situation than get them involved, train them properly, and then have them share in the responsibility. And if I'm involved in maintaining the equipment, I'm going to be a little more careful how I operate it. I think most people would agree with that. Always exceptions to everything, and that's one of them. But I think most people would accept that. On the operator side, we've got to make sure, you know, we answer their question. Well, you're asking me to do more. And we are, you know, very, very likely we are. So how are we going to respond to that concern? And, you know, I'll talk about this later. We got to make sure what we are asking operators to do, they indeed have the ability and, very importantly, the time to do it. So if they don't have the time to do it, they're not going to do it. And I've seen this occur many, many times where organizations ask operators to do their part for autonomous maintenance, and, you know, they're not doing it. And then I get a call, I come in, take a look, and talk to the operators, and like, I don't have time to do this. And I have to tell you, 9 out of 10 times, they are correct. When we actually get stopwatches out or a clock and start, you know, really looking at what they're being asked to do and the nature of the equipment that they're running, they don't have the time. So we'll talk more about that later. But, you know, in the kickoff to this, we have to make sure that we answer those concerns on both parties. This is more work for me. And we can get into some other issues there, topics like compensation, you know, in a union environment. There could be other issues that have to be resolved up front. And then on the traditional maintenance technician side, you know, how do we answer or respond to the concerns of, hey, what am I not doing a good job? Is that why you're doing this? And I'd be interested to hear from those of you who have gone down this path at the end, when we have a good 15 minutes or so for Q&A and really conversation. I would like to hear what your take has been, what your experience has been on this in approaching these different parties with this concept. And what did you find that worked or didn't work? So what we end up doing then is looking at the tasks that have to be performed by everyone, just what's needed on that equipment. And we make two lists, basically. And it's an iterative process to make this list. As I mentioned before in the beginning, we can do, I can see operators doing this, and that, inspection, lubricating, cleaning. But we want to kind of maybe strive to include some other activities as well. But we basically just start with one list of all required maintenance-related tasks, and then we go line by line and sort them into two separate lists. What do we feel the operators can do with some training and time, and what maintenance still feels they need to continue to perform. All right. So again, the iterative process. It could be that we even roll this out just with the basics of inspecting, cleaning, and lubricating. And then we find out, people start getting more confidence. The operators are like, I can do this. The maintenance people are getting more confidence. And then we can go through the list again and say, is there anything else that just makes sense for the operators to do, which could be checking still, more inspecting. If you think of the predictive techniques that we talked about in the first session, if you participated in that, if you attended that session. So just remember, it's not gonna be a one-time activity of creating these two separate lists. It could be, iterative changes would be made, especially if we can simplify more tasks and get that comfort level on all parties. So now we've got this list for the operators. We have to educate and train them in it, even the basics. So even if it's inspection, what am I looking for? So maintenance personnel, as I mentioned before, will typically deliver this. And that means, again, they have to be willing to share knowledge. Many are, but not all. There's that need for collaboration again. It's a common theme. And not always, as I've learned over many years, not always do the internal maintenance personnel possess the requisite knowledge and skill. And that's where we have to bring the OEM in to give training to everyone, basically. My most recent effort in this area, just late last year, we had to bring the OEM in over a series of visits because the internal knowledge for running and maintaining this machine, kind of a line of a series of machines, just did not exist. The people that had it had left, and the equipment was only 5 years old. It was remarkable to me, but we had to go get the OEM in, and that worked out brilliantly. Not only did they get training, but we recorded them, videotaped them, all of that. So we captured that knowledge and we're able to use it again as maybe we had some changeover of operators. So how well operators will pick up the concepts, which again could open up other possibilities, it depends on, their comfort level, their technical expertise, but a lot of it's what goes on the list, at least initially, is not too technical in nature, at least in the early iteration or iterations of this. Now, we don't just say go do it with the training. We really want to look at each task very closely and see how can we simplify this. And it could be things like you want me to inspect something. How can I provide greater visibility to what they have to look for? Oh, I got to walk around this machine to look at this gauge, a pressure gauge. Can I move the pressure gauge to where I don't even have to move as the operator? You're going to see pictures of examples of this from over the years. Can I improve accessibility? Make it as easy as possible for the operator to do what we're asking them to do. Can I reduce the tools I need and fasteners, or all the above? just trying to make it as simple and easy as possible. And again, that could open up the possibilities for other tasks to be included as part of autonomous maintenance. Oh, operator, you can't ask operators to do this. They have these tools and they got to get access to this, and this part of the equipment. Maybe we can do some clever things to make it more accessible, more visible, just simpler in nature. So here's some examples of visible, accessible, and easier. You want me to read a label, a gauge? Put a gauge label on there. If you notice, little green means good, right? If it's outside of green, then the operator knows there's a problem. Now, maybe they have to, part of the operator-assisted maintenance or autonomous maintenance program is they make a little adjustment. Or maybe not. Maybe, the response to that non-standard condition would be to call maintenance. But you want to make it crystal clear. The dial is in the green or not. Temperature-sensitive labels. We want you to check the temperature of this motor or some other part of the machine. Well, I need a tool to do that. We don't have a lot of these sensors or temperature readers. Well, they have these very inexpensive temperature-sensitive labels. I don't know, they're under $1, I believe, each. And we put it in a visible place, draw a little line, and what the label will happen is it'll change color based on the temperature. And we can draw a line of what the kind of the limit is. And once again, the operator can inspect this very easily, and that could trigger a response either by the operator, but maybe it's something they have to do, or maybe they have to call maintenance technician. Want to check fluid levels. Well, how do I see fluid levels from a little bit of a distance? I don't have to be all up close. Zebra stripes applied behind the tube here of liquid, and you can just see how the stripes change in orientation. It gives you an idea of the levels of the fluid. So it's right here, right where my cursor is. I assume you can see my cursor. And then we've got some lines, kind of max mins, that say as long as it's in between there, it's all good. And you'll note that numbers, they correspond to the operator's checklist. So it should be crystal clear what they're checking and what they should do based on what they see. So those are just a few little simple examples of some very cost-effective visual techniques that we can get. The zebra stripe material comes in like a card stock. You just cut it to size and affix it behind the sight glasses there. The one on the right, more gauges and gauge labels, but this particular example from a company many years ago, we moved the gauges themselves to make them more visible. So it didn't require the operator to have to walk around a very large machine. We moved it in a way they could just glance over from their normal operating position and see what the gauges were reading. So that's the point of the right example. The left one was, we've got to open up this cover. Obviously it's affixed in some way. We need some tools. And, how can I get access and visibility? There's a filter material in there. And how often is it going to be where anyone, maintenance or operator, we'll say the operator here, would take the time to open this up and find out the filter material does not need to be changed. And if they do that enough, they just won't do this for long. So what we did is we cut out part of the cover, and not without, we didn't jeopardize safety, the safe operating. It was just a cover. It wasn't kind of functional in any way, just to keep stuff out. We replaced the cutout with some plexiglass so you could just see directly in the condition of the filtering material. These are actually, the plexiglass here is affixed with just some Velcro, so don't even need a tool to remove it and then replace the filter. So think of the left example. You don't have visibility, accessibility is a little more difficult, you need tools. Now we make it so easy that it's reasonable to ask a operator to do not just the inspection, but also maybe replacing the filters. So These are old examples, but old does not make them bad. Visibility could be provided with mirrors. That most recent effort I was referring to, where we had to bring the OEM in to teach us all about the machine, we added some mirrors to it, because it was difficult to kind of look around behind some areas. In some cases, we are able to affix the mirror in a position, so the operator is working on maybe the front side of the machine, and they can see what they need to see on the back side with the benefit of a fixed mirror. Sometimes it's not fixed, it's just handheld, and that's what we used with the company I was referring to. It was more of a safety concern than anything, popping their head around the corner, they could hit their head in little tight quarters. So we gave them, some handheld mirrors that did the job for them, gave them the visibility they needed with minimal motion and no concerns on safety. Of course, with any tools, we have to 5S them, make sure there's a place for them, and set them in order so there's a set place for them. The example in the middle is the filter material is on the outside of this panel box, where before there was no filter. But this gives visibility. Do I need to change the filter or not? You don't even have to open up the box or the panel to see. And then we would have pre-cut filter materials stored at point of use, much like the example on the right here. But the other point I want to make here is we actually changed the direction of the fans. So it's drawing air in through the filter. Before, it was not doing it. It was taking hot air out and drawing in dirty air. So we had to change the direction of the fans. So it's not just put a filter on. There was a little more to it than that. But certainly something we could reasonably ask an operator to not just inspect, but change out the filter material as needed. Similar as this filter for this motor, it's drawing in dirty air. Why I like this picture, this example, is we've got the cabinet over here of all the materials, including pre-cut, right to the proper size filter material for the operators. Make it as easy as possible. It's not in some maintenance shop. It's right by the machine, all labeled. So you can see we applied some good 5S to these cabinets and make it as easy for the operator to do. Like lubricant points, getting some good stickers on there, make sure it's easy to know where they are. Sometimes those lubricant points are hidden, unfortunately. So some just pre-made labels that can hold up in the environment, and putting those in areas to make it crystal clear where the lubrication points are for anyone. If we are asking operators to lubricate and there's different lubricants, we color code those. In this example in the middle, it's a green bottle with not just a color, but a little symbol. And you can't really see on the other side of this cap here with the tag hanging from it, that's green as well. So the operator knows green lubricant goes in the green hole. If there was different colors, we'd have different. You can even get little caps that are colored for lubricant points. This is more pouring in rather than like a grease gun or something with a very, connector there. And you can get color-coded caps that are color-coded by the type of lubricant. Sometimes we've done it by the frequency of lubrication. Whatever you're going to do with color, make sure everyone understands it. Have some legend somewhere to remind everyone what the colors mean. This is one of my favorites on the right. These are several fasteners holding parts of this machine together. And, previously operators were asked, hey, go check tightness of these bolts. So an operator had to go get a wrench. And now we can give the operator a wrench, and have that stored at point of use. But even better here, And they think about it. They would get the wrench and put it on each bolt head, and oh, that one's tight. Oh, they're all good. You know, they do that a couple times, and no bolts are needed to be tightened. They're not going to do it at the frequency they're supposed to, and I wouldn't blame them. What we're showing here is torch stripes. In the old days, I used to use ladies' fingernail polish. That stuff would hold up under anything. Now you can actually get paint, torch striping paint. And it's just a line. I don't know if you can see the lines here, but all we're asking the operator to do is you don't need a tool, just go look at the lines. If you see the lines are broken, you know that one of the bolt heads is coming loose, one of the bolts is coming loose. So you can make it visible, simple, remove the need for a tool, which saves time, and you got a better chance of operators doing these things over time. So then don't just say to the operators, here, go do these things. Do everything you can to simplify. Make it accessible, visible, and simplify. Remove the need for tools or some tools, you know, wherever you possibly can. Then we develop standardized work for what we're asking the operators to do. And these are just two examples. You know, basically it's the tasks that we're asking to do, but very importantly, how to do them. You know, with what we call key points. Key points are safety. You know, maybe there's a safe way of doing the task, or, you know, so we want to make sure that's documented and operators are trained in that and have standard work to remind them of those safety key points. Quality is a key point, a category of key point. You know, so they have to do it a certain way. So, you know, there's they're going to get the right result, the right quality result. And then kind of a simple, like an efficiency key point, for lack of a better word. Maybe we found simpler ways of doing it and we want the operator to follow that way because it's easier for them. So we've got our tasks and key points in this example. They're using like a legend to kind of highlight what key point it is: safety, quality, efficiency. Very importantly, we have the frequency that we want to do them, and that can vary. I think these were, I forget, this was weekly, this was a variety of frequencies, daily, quarterly, you can kind of see in this column. This is from a printing press at a printing company I worked with. Expectation of the time required. Now, how long does it take? That's what this column here is in the upper right example. You know, how many minutes? We even have at the bottom kind of the reasonable expectation. Oh, this is, 5 minutes a day we're asking them, or 10 minutes a week. You want to have that on there because you want to make sure, again, we're being reasonable what we're asking the operator to do. And so get the watches out, time it, make sure what we're asking them to do is easy. We'll even resequence the standard work in a way that helps the operator maybe reduce their motion, to complete all these tasks. And then what's beautiful these days, it's very easy to take some pictures, add them in, as you see in both of these examples, to clarify anything, what we're asking them to do or how to do it. And then numbering. Numbers on the standard work should match the numbers adjacent to the area on the machine that the autonomous maintenance task is to be done. So that all should match up. Make it crystal clear. So this is where I think we run into some problems about we're not being reasonable with operators. So I get this call over the years from time to time. Why can't I get my operators to do these things? And I sit with them and they say, I don't have time. And when you look at it and you see what the time is and you look at the nature of the equipment, if it's a highly automated piece of equipment and I can do my required tasks without interrupting the equipment, great. An operator should have time. But if it's semi-automated, the operator's still there and doing something, not just kind of babysitting the machine, we got to make sure that they can do it. If it's a very manual machine, it's pretty crystal clear. I have to stop what I'm doing and go do this. So we have to kind of look at the nature of the equipment, how autonomous it is. And I'm using that term a little differently than autonomous maintenance, as well as the nature of the task. Some tasks I might be able to continue to operate the machine. Great. Some tasks I have to stop the machine. And this is where we have to make sure that we are accounting for these tasks in whatever scheduling or capacity planning process we have. Because if we're not, accounting for this, and operators are being held accountable for unreasonable throughput goals, they're not going to do this for long. When push comes to shove, this will get pushed aside. So we want to make sure that we actually account for whatever the time is. If we have to stop the machine, if it's affecting capacity and potentially our scheduling, we have to account for that. And that's why even schedulers sometimes are involved on this team, not just maintenance and operations, but often I have planners or schedulers, whatever title you use for those roles, involved in this. All right. So sometimes when we encounter that they can't do everything we need them to do, the operators, we have to make adjustments. So it could be we can change the frequency of certain tasks, kind of take the burden a little bit, reduce the burden a little bit. In a multi-shift operation, I've had some shifts do certain tasks and another shift do another set of tasks. So we got it all covered like every day, if we need to do things every day. You don't want to overdo these things. If you don't need to do certain tasks every day, then don't do them. People will kind of see that it's unnecessary and they'll start questioning all of this, and that's not a good thing. Sometimes we've had to move some tasks back to the maintenance responsibility because it just was too much for the operator. Again, I really kind of want to emphasize this because I think this is where, at least from my experience, when I get calls in after the fact, seems to be where they run afoul. They're asking too much, or they haven't really taken into account the nature of the task and the nature of the equipment, and therefore what they're asking the operators to do is unreasonable. So, just some suggestions there. If not even if you, at the beginning, give these some strong consideration so you don't head down an inappropriate path and just upset everyone. So think about incorporating autonomous maintenance visual management. So what do I mean by that? On the left side is an hour-by-hour board or day-by-the-hour board. People call these different things. And, it's where we have a plan of throughput and we ask operators to track their actuals. And then, if they don't match, make some comments, why? And they would put comments usually on the right column. So there's, hour by hour through a shift. This is for 3 shifts on the same machine. And, they would have the plan, actual. Sometimes it's cumulative. And then, but very importantly, they got to record, why they didn't meet the goals. So actually, this is the plan for the hour and the actual, or the cumulative and then the actuals here. So if I'm asking operators to do autonomous maintenance tasks and it does indeed affect throughput, I need to be more reasonable with my plan, my goals, or my targets here. So we build that in. If there's certain times that we know we do the autonomous maintenance, just put it right on there. Put autonomous maintenance in this hour. That's why you'll see the goal or the plan for that hour is less because it's the operator's got to do the maintenance test. More often than not, that's the case. So we can embed it right in if you're using day by the hour or hour by hour boards. We should put it in there. Any sort of visual management that we have, we're usually tracking safety, quality, performance, some metrics here, maybe day by day, is good. Let's add some means of tracking autonomous maintenance. It could be anything it could be like a metric of the percentage of time that it was done when it was supposed to be or not. So we can kind of track the task completion rate, like a percentage. Or maybe there's 10 tasks, but they only are doing 8. So we would track that day to day. So if you have visual management going on and you're out in the shop, usually by a line or by a grouping of machinery, maybe for a department, think about adding autonomous maintenance tasks to your visual management, maybe some metrics for it. So over time, you got a better chance of sustaining it. And when we're not hitting the goals, we'll know sooner than later before we have a big problem. Often this is self-reported. So this goes back to the cultures piece and the trust and the working together piece, the collaboration. We have to make sure that we encourage operators to, if they can't do it, that's not a negative reflection on them. We need them to highlight that, either on an hour-by-hour board or some other part of visual management. The right example is one of my oldies but goodies. This is a board for a machine that's on the right out of the photo. There is a list here of operator-assisted or autonomous maintenance tasks. A lot of lubricating and cleaning inspection, very classic. We've got some pictures on the right here just to clarify what we're asking operators to do. Very importantly is this area on the left here. What they are little holes drilled into this board, this plywood board. And it was a 3-shift operation, and they could work as many as 7 days a week, but definitely a 3-shift operation. Now the board is cleared. This is like the beginning of Monday, they would clear the board. They must have been golfers or something because they used golf tees for this. And so for each, there's like 3 for each item, each task. And there's 3 rows because that's represents each shift. We were asking each shift to do these tasks. And if an operator on first shift, did the task and didn't find a problem, it was an inspection type of thing, they would put a green tee in the hole for Monday first shift. And, if second shift came in, did the same thing, didn't see any problems, they put a green golf tee in. They had 3 colors, green, yellow, red. Yellow would indicate that they found a problem that they were able to resolve themselves, add lubricant or and maybe they, earlier than they should have. Or like maybe some fasteners were loosening up and they had to tighten those up. So yellow meant that they saw a condition and they were able to address it themselves. And then if they found the condition they couldn't address, a red golf tee went in, and then that triggered them to put a maintenance work order in, call a maintenance work order in. And they had like a log for the maintenance work orders, a little history too. Now, why I really liked this approach was, let's say I go in and some bolts were loosened, I tighten them up. Second shift comes in and the same bolts are loosening up. And if the yellow tee, colored golf tee would tell me, well, first shift had that problem too. So we're not getting the root cause, right? Something else is going on. Maybe the machine is vibrating a lot more than they should, or the bolt fastener, the threads are starting to loosen, that kind of thing. So you can actually see recurring problems, like yellow conditions going from shift to shift. You could see problems that need, maintenance to follow up on, any red. So like the supervisor could come by and say, did you put your maintenance work order in? Yes, it's red tee. Let me go follow up and see where they're at with it. So kind of like that. And this is Monday morning where they took all the tees down and put them in a little bin down here. But I kind of like that approach. I've done it with magnets, little tiny magnets on magnetic boards. That's pretty much what we do more these days, dry erase, magnetic dry erase boards. But hopefully that gives you some ideas, because whatever you can do to make this more visible, you've got a much better chance of sustaining it over time. I can show you a lot of pictures of this, but hopefully these 3 give you a good idea. So that kind of covers the topic. Again, just like with predictive maintenance, not too complicated, right? But the challenge is in doing it. So that's why I want to open it up now to not just questions you might have on the topic, but experiences. We had a lot of good experience. William was on the call. I think he's on this one. He had some good contributions. I don't know if Adrian was on this, is on this one, but there was a number of you really contributed. So I'd like to hear what your experience has been in trying to apply autonomous maintenance in your facilities or maybe previous employers. So we all can learn what worked, what didn't work. Did you run into some of the difficulties that I conveyed, or maybe it was just me? We'll give you a moment to type it into your Q&A there. I'm sorry, type it into the Q&A. Should be on the side of your screens. That's what it is on mine. Oops. Anyone have anything to share? This worked out really well last time. Some great learning. I was hoping for the same. Anything not clear on anything that we covered? We'll give it another couple minutes. Last time it took a few minutes, Rose, for people to type in their thoughts and comments. Nothing yet. I must have answered everyone's questions on the topic. That would be rare. All right. So hopefully we'll see you at the next one, which we're going to talk about how to prioritize. And I've got a couple suggestions there, even a case that, oh, here we go. Julio, do you have any examples of facilities that have successfully implemented AM in the U.S.? Many over the years, none, I don't know, maybe one that's current that I'm working with. But why do you ask? You know, a lot of the pictures and things are from companies I worked with, all of them. Why do you ask, Julio? I've had many. Maybe some on the call today, in the webinar today. Anyone on the webinar today have an autonomous maintenance program? You could share what you've learned and what worked, didn't work for Julio. Maybe even offer a visit. I don't know where he's located. I don't know why he's asking this question. Julio, are you still there, sir? I don't know. So does anyone?
He just added a statement.
Yeah. You know, benchmarking can be a visit. Benchmarking could just be some interaction, you know, a phone call or something. So I'll assume the easier path. Is there anyone on the webinar today that has applied AM, you know, autonomous maintenance, and be willing to have Julio reach out to you? Like we had folks just 2 weeks ago that were doing good work in predictive maintenance. while we're waiting, Rose, is there a forum that he could post to an SME? Hey, anyone out there, beyond this webinar?
Yep, we can get back to Julio with some examples and more feedback on that.
Mm-hmm. I know some of the other associations have like a forum you can post a question,
right?
And people hopefully respond. Anything else on anyone's mind before we wrap up? One thing Julio, would guard against with benchmarking, don't focus on where they're at today. Make sure you understand the journey that they went through, because it's not easy. And often after the fact, an organization kind of forgets or doesn't bring up the difficulties that they encountered. So whenever you benchmark, always focus on not just the results that they achieved, but the process they went through to get there. So again, hopefully see some of you in 2 weeks. It's going to be on September 4th, I believe. Right? At 1 o'clock Eastern time. And again, it's about prioritizing. If you have a lot of pieces of equipment and complicated equipment, where do you start? It's the question that I often get. So we'll give you a couple approaches to that. So hopefully I have a little case study from a food manufacturer I'm working with currently on this subject. So hopefully to see you then. All right, Rose, should we wrap it up?
Yes, thank you for attending today.
All right. Go forth and apply, everyone. Bye-bye.